really essential skill of dividing radicals with monomial denominators. Okay. To recap, what's the answer? 15x squared. Why? Because you do 5 times 3 and then x times x. And that led us to 5 root 2 times 3 root 5 to get us to 15 root 10. Right? And again, we took the coefficients and we took the arguments, and that's how we got it. Right? Okay. Well, now we're going to work on dividing. Now, cast your minds back to grade 3. What's that? Now, this is where it gets weird, because I asked the morning class what that was, and then I asked why, and they couldn't tell me. Why is that 3? Ashneet.
3 goes into 9 3 times.
Okay. What's another way we could say it? Sam? 3 groups of 3. Another way we could say it? Manru? 3 times 3. Joseph? 9 divides into 3. 9 divides. There's a million ways we can talk about this, yes? We can all do it. Agreed? Okay. Now, logically, what do we have there? I have 4 divided by what? 2, which is what? 2, right? Okay. Now, again, just like here when we had the same indices and we just multiplied 2 times 10, what do you see here? The same indices. So what do you think we can do with 16 and 4? Divide them. So this also equals the root of 16 over 4, which is the root of 4, which is 2. Everybody good? Yeah? Okay, so now you should all already be at this spot. A n root x over b n root y, because they have the same index, is a divided by b n root x divided by y. Everybody good? Now, you're intelligent young people. Will this always be a tidy piece of division? No, it will not. For example, what if it was 15 over 6? He waited patiently. To what, Satjot? To what, Satjot? Right, 5 halves. You bring all of your math to the party, even if it's a surprise party. You bring all of your math. Okay? Okay. So let us look at this very first one, which is as simple as it gets. What do you notice about the coefficients? They divide quite tidily. To what? 9 divided by 3, which I'm going to highlight in green to keep the colors going. Then, are they the same index? So I square root. And then to keep the colors going, what's going under there? 18 divided by 6. And what do I get? 3 root 3. and I am done diddly-un. Just like every time you have tidy division when there's no radicals involved. Are you all good? Hold your breath. Swallow 5 times. Don't laugh. It is hard to do. No, we're not beatboxing. No. All right. Let us look at the next one. Now, if I gave you this, and put brackets around it, what do those brackets do? They hold it all together, right? If I were to put an exponent out there, that exponent would have to go to everything, yes? Now, we all know that when a square root encompasses everything, is that not the same as root 15x cubed y squared over root 3xy squared? Because the exponent goes, or the radical sign goes to everything, right? Now, where does this 15 live? Numerator or denominator? Numerator. So now, what do I have? I would have 15 divided by what? 1, and I would have that radicand divided by that radicand. Now, Mr. Myers has just said you have to bring all your math knowledge to the party. Do we know how to divide exponents? Of course we do. So what is the answer here? 15 root 5x squared. And that's it. But are we done? Why not? Because that x squared is coming out to get 15x root 5. Are we all good? It's just dividing like we've been doing since the 3rd grade when Mrs. Bad Crumble first gave us 9 apples in our group of 3 and asked you to give everybody the same amount of apples. Right? Okay. What is different in C? And those of you that have been in my class long enough know that this much white space means there's something coming. What's wrong with C? It is already as simple as it could possibly get with the knowledge that we already have, correct? All right. Now, if you were in my honors class last year, pre-diploma 10, you already know what to do here. I lie. You have been shown what to do here, but it has long since fallen out of your head. Correct? Yes. Here is the problem. This is not allowed. No irrationals in a denominator. Simply because if you have an irrational in the denominator, you don't have a rational answer, do you? All right. So, because this is not allowed, we have to do something to get rid of it. Right? Now, you have lots of examples in math where you are given some expression, 2/3, and asked to change that expression's looks, but not change its value. What are some things you could do to 2/3 to keep it as 2/3, but make it look different? Zach. Okay. Preston. I nearly called you Parker. Where the hell did that come from? Preston. I could multiply it by anything, couldn't I? I could multiply it by y. As long as I multiplied it by y, I keep the same value. Excellent. Is there anything else I can do? If I can multiply, can I not divide? Is this not the same as 1 over 1.5? Okay. What else can I do? What if I had negative 2? Oh, this will be a good one. It'll bring up what we're doing in the next unit. What if I had a plus b plus 3a minus b? Does anybody remember what I can do? Sorry, I screwed that up. B minus A. Does anybody remember what I can do here to keep it looking good? Pardon me? I can make it A over A. I can make this one negative A plus B. I can make this one A. Negative A plus B, okay. And then what? Oh, this one needed to be A minus B to do this. Sorry, guys, I'm screwing this up. It's the end of the day. Now, what could I do with this to make it look like this? Okay, nobody remembers. That's cool, that's cool. We haven't done factor in a long time. I was just seeing. Okay, never mind. Yeah. But not one of them. I got to take something else out. Gerline? Yes, how do I take a negative out of somewhere? Right, I would divide by negative 1, right? What if I need to change it the other way? Could I multiply by negative 1? Right, so I can multiply by the same number. I can multiply something by 1, right? I can divide something. There's all kinds of stuff I can do, right? To get rid of stuff I don't like. So what here do I not like? Do I care about the 3? I only don't like the root 7, yes? So how, indeed, can I get rid of a root 7? I could multiply by root 7, yes? Because that will give me 3 root 49, which will give me 3 times 7, which will give me 21. Yes? Which is all well and good, except this is a fraction. So what must I have up here to keep this value the same? I must have root 7. Because what is root 7 divided by root 7? 1. And what is anything times 1? Stays its same value, yes? But it's going to look different, isn't it? Because up top here, I'm going to have now 2 root what? 6 times 7, just like we reminded ourselves at the beginning, which is 2 root 42. Correct? Does 42 get any simpler? 2 times 3 times 7. Any pairs? Yes or no? So we are done. And this is your finished answer. This process is called rationalizing the denominator. That looks like denominator. Denominator. Do any of you still have words like that you actually have to sound out while you spell? Like I still do for denominator. I can't just say denominator. I have to go denominator. Reciprocal is another one. I have to actually write out, and I had to write it twice this morning. So I had to write and I was spelling. Oh no! I had to erase it. Reciprocal. Yes. Legislature or legislative? Yes. Yeah. All right. Now, ladies and gentlemen, are we all good? Of course we are. So let us look, cabbages, at the first one. What do I see? I see 7 over 14, and I see root 5 over root 6. Now, some of you are going to right away say, oh, I can simplify that. To what? 1/2, right? Okay. So let's see if that will work for us. If this becomes 1/2, now I have root 5 over 2 root 6, yes? Does everyone agree? And that 1, it's there, but it's not really there, yeah? Right? Okay. So what there bothers us now? Is the 2 bothersome or is the 6 bothersome? The 6. So what should I get rid of? The root 6. Agreed? All right. What is root 5 times root 6? Root 30 over 2 root 6 times 6 is what? 36. And I get root 30 over what? 12. Hey, Mr. DeVries.
Hey, predict tens?
No, this is pre-calc 11.
That's my favorite. Did predict tens, did you do quadratic equations with them last year?
Did I do quadratic equations with them? We did finding roots of and factoring of, but they didn't see the quadratic formula.
Okay, so they factored to solve?
Oh, yeah.
I figured they must have because they look pretty familiar.
Yeah. Well, that is this. And instead of factoring that, it equals 0. So, of course, that's x plus 3, x plus 4, and then either x plus 3 has to equal 0 or x plus 4 has to equal 0. So x is either negative 3 or negative 4. But you have all seen that. Okay, stop. Are we good? Does 30 get any easier? 2 times 3 times 5. Any pairs? No, so we're done. Everybody cool? Everyone's good? Okay. Now, just for academic purposes, okay? Watch. Everybody agrees we've got an answer. Everybody follows the thinking, right? Okay. What if you didn't see that 7 and 14? It just didn't register. For whatever reason, you didn't see that was 1/2. Would you get the same answer? Of course, because what do you want to get rid of? Root 6 over root 6, right? So now I have 7 root 30 over 14 times what? Root 36, which is 7 root 30 over 14 times 6, which is 84, right? Now you're at a point where, oh, of course, 7x over 84, obviously I would deal with the numbers. And of course, 7/84 equals 1 root 30 over 12, and then we would get rid of the 1. It doesn't matter the direction you go, but you have to remember all the math. Everybody cool? Okay, now, just like in multiplying, we have an option. We can simplify first. Should we? Every chance we get. Because why would you want to deal with the square? Like, if you have just been learning steps, here you're going to go root 18 over root 18, right? Who wants to simplify 50 times 18? I sure don't. So what would I do here first? The same thing I've been telling you, and the same thing your previous math teachers have been telling you since the first day. Mrs. Bag-Crumble gave you 9 apples and said divide it up in your group of 3. Simplify. What are you going to do with that 50? I would use 25 and 2. What are you going to do with that 18? 9 and 2. And now my expression becomes what's coming out of there. What's already there. So what do I got? 30 root 2 over what's coming out of there? 3. 15 root 2. Root 2 over root 2, what do we get to do? Cancel. 30 over 15, what do we get? 2. Done. Everybody cool? It's all stuff you already know. The only thing that's new is this. But we only have to do that if a radical ends up in the denominator. Okay, it's one of those negative exponent situations. You should see it and it should look wrong to you. I know how to fix that. All right? So we'll do G, H, and A together, and then I'm going to shut up. All right? What? G, H, A. Because I didn't feel you needed all the stuff before. I didn't feel you needed A, B, C, D, E, and F there. And once you've seen it with a fraction, all the rest of them are the same. That's why this is only notes. So, what do I have there and there? Oops, that should have been pink. What do I do with the green side? Does it divide tidally? So can I divide it? What do I get? -2. Root. Does that divide tidally? Yes. Into what? 3. Is there any denominator left? So am I okay? Yeah, sure, you betcha. What about this guy? Does the green divide tidally? Into what? Not 2. 1. 1/2. Does the pink side divide tidally? Into what? Where does that 5 go? Do I need that 1 there? No. Now, let's say again, oh, Mr. Myers, no. I didn't see that. I'm going to multiply by root 10 over root 10. And I'm going to get 4 root 500 over 80, right? And 500 is 5 times 100, yes? What's going to happen with that 100? I'm going to bring out 10. 40 root 5 over 80. 40 and 80 work together to make 1/2. Everybody good? Yeah? Okay. What are we doing with A? What is that really? Because right now it's ugly. What's it really? Root 27 over root 10, yes? What's ugly about root 27? What is it? What is it, Zach? It's irrational, but can we simplify it? To what? 9 and 3, and then what comes out? So what do I got? 3 root 3 over root 10. Am I okay with that? No, what's yucky? Irrational in the denominator, so I get rid of it. What's on the numerator now? Over. Now, some of you might need to actually see root 10 times 10. But most of you are probably doing this in your head. You know that it's 100. You know the square root of 100 is 10. So you should be able to put together that the square root of x times the square root of x is x. So we should be good with saying that is 10, yes? Do we stop there? Of course we do, because this part of the fraction is as small as it can be. Everybody good? All right, turn the page over. You are going to do C and D, then we are going to do B. So you go ahead and do C and D right now while I... Yeah. Yeah. Man, but I did a better job with that with you guys. There's 30 sets of eyes in here. If the little red dot's not there, tell me. You're all willing to tell me when I'm recording something that you don't think I should be recording. But when I'm doing math, you're paying attention. That's funny. I don't know. I don't know what happened. I know. But my pen goes hinky more often now. So... maybe next year, Henry, it'll all come together and my pen will work and it'll stay connected. This whole bit. But all the work's there. Okay, so I'm going to turn off the screen. I'm going to do F, G, K, and L, show all the work, and it'll record while I'm doing it. Now, of course, I am going to show all the work. I'm not going to do anything in my head. But does that mean you have to write it out that way? No. Yes, go. Has everybody finished FGKL? No rush. I am not trying to rush you. I just want to know when I can put it up on the screen. If you have finished F, G, K, and L, go ahead and attempt A and B of the next ones. Everything in blue is done. What do you mean? Like tidy? Oh, thank you. I do try to keep my penmanship as tidy as I can for you guys. Henry, which one? I. L, yeah?
How'd you get the negative up to the top?
Oh, okay, fair enough. It's all the same thing.
Oh, yeah,
I just like the negatives in the numerator.
All right.
Good question, though. It could also have been in the middle, right there, or I could have left it down there.
Yeah. All right.
Anything else? Sam.
For L, where it says you have 30 root 5 over negative 3 root 3.
Yeah.
Where does the 3 go?
Which 3?
Like on the numerator, it's negative 3 root 3. The one that's the coefficient, where would that be? Like, did you put it inside the square?
No. What's 30
Oh.
divided by 3? Okay. Anything else? Tickety-boo? Everything's coming up aces? We're all good? All right, now. A is tricky. Again, because a great many of you are immediately going to cross those out. I made a big deal out of it earlier with your class because I forgot to make a big deal out of it earlier with the earlier class, and a bunch of them did that. So that's why I knew it was something I had to remind you of, right? Now, let me show you just for a second because, a bunch of you are like, you won't ask because I've made a big deal about how you can't do it. But some of you are thinking, why can't I do that? I know some of you are. It's okay that you're thinking that. Let me show you why you can't. That is the exact same thing, yes? And you want to do that, yes? Which means this is 6 plus 1, yes? Which is 7, right? But that is not what this is it? This is 6/5 plus 5/5, which is 6/5. Oh, sorry, which is, I just wrote equals twice, 11/5. Okay? Now, if you write it out this way, you can cancel that, and you get 6/5 plus 1, which is 1 and 6/5, right? Which is 2 and 1/5. Yes? Which is that. All right? Because they are added, we cannot do that. What you're thinking of is this. 6 times 5 over 5. There, you can cancel it. Because this one is 30 divided by 5, which is 6. So when you cancel, you're left with that 6. One is multiply, one is add. They are different, okay? So knowing what you know there, you cannot do this, so you have a choice. The first step is either root 7 over root 2 minus root 2 over root 2, and then simplify each one. Or root 7 minus root 2 over root 2 times root 2 over root 2, and you distribute and simplify later. Both are equally effective and will get you to the right answer. Okay? You choose. McKenna.
For the second example you did in green, when you're distributing the root 2 on the top,
Yeah?
it would be, what did you just root 14 minus 2?
Yeah, it root 4, which is 2.
So then could you just switch that and be negative 2 root 14?
Negative 2 plus root 14, yes. Because it's not multiplying, right? And then that would be over 2. Right? Oh, why am I erasing that? And then, of course, if I were going to finish off the green one, I could leave it like this, because I got no radicals in the bottom. But I could also do root 14 over 2 minus 1. These are the exact same thing. If I finish this one off, that becomes root 7 over root 2 minus 1, right? This root 2 we don't like, so we multiply by root 2 over root 2 and get root 14 over 2 minus 1. And get the exact same answer 3 different ways. Now, I know that some of you will say, oh, I hate it when he teaches us more than one way to do it. It confuses me so much. Don't learn more than one way to do it. Learn the way that works for you. But there is no question that kills math teachers more than when you ask, is it the same if I do adding a negative? Because that makes us go nuts, because it makes us think that you don't know how to do math. Okay? Yes, Ashni. No, because the negative has to be the 1. Okay. Everybody good? Now again, remember, is this allowed in B? No. You can only do that if you split it. You can do this. And then work cancellings all over the place. Or you can do root 3 plus 2 root 2 over 2 root 3 times root 3 over root 3. Now, some of you will even say, but Mr. Myers, I need that 2 there. I need to remember that I'm multiplying by the whole denominator. It'll still work out. You'll just have a bigger fraction to simplify later. Because remember, the only thing you're trying to get rid of is the root. So you only have to multiply by the root to get rid of the root. Okay? Your choice there. Has everybody attempted B? You have? Has everybody attempted B? Okay, work on it. I'm going to work through both of these. You can compare it to yours. No, because 2 and 6 share a common factor, 2. So I divided the 2 out of the 2 to get 1 and divided 2 out of 6 to get 3. Would you ever leave this factor with this fraction with Mrs. Bad Crumble? 2 over 6. No, it's 1/3.
So you just leave it as the highlighted one.
All 3 of those, 2 of them you can see are the same, but if you stop there, you're still okay. Alright? Now, you will get some math teachers that say you should finish it as far as you can. There's a reason kids hate school. Okay? Bring me a concept. Don't bring me minutiae. Do you understand what I am saying? If you don't know the word minutiae, you of course should know that the root word is minute, which means really, really small. Don't sweat the little tiny details in looks when this does everything I need it to do. Okay? Everybody good? Yeah? All right. It's 2:12. You have 13 minutes or 12 minutes or some crap. Do these 2, and that's it. We've had a good balance of talky, worky, talky, worky. And we're not doing any more work on this, because this, you will notice this keyword, monomial. Tomorrow, the denominators look like that. Yeah. All right. You want to take the quiz? Take the Know Your Teacher quiz? A and B are homework.